all, welcome back to my channel. So today is the first time I actually submitted the solution for the third question on a Leetcode weekly contest, and it finally got accepted. This will be probably written down in history books. So let's look at the question. It's weekly contest 473. Stable subarrays with equal boundary and interior sum. So it's exactly what the question says. You're given an array capacity as input, and we need to find a subarray from L to R, which is considered stable. So this subarray is considered stable if its length is at least 3, and if the first and last elements are equal to each so the first and last elements are equal to the sum of all elements that are strictly between them. That means excluding L and R. So they've given the equation over here. So we need to find the number of such stable subarrays when we're given the capacity as input. So we can look at the example that they've given here. So 9 3 3 9. So you can obviously see the entire array capacity itself is stable because 9 and 9, the first and last elements are the same, and 3 times 3 is 9. So all the elements in between also have the sum of 9. And the subarray 333 is also stable because the first and last elements are both 3. So now that we know what the question is asking for, let me directly go to the code, because this question, it's quite literal. There's not much interpretation to it. So yeah, and my code is a bit diabolical. So don't question it. I'll just say it. I'll just walk you through it. So first of all, I am storing the sum of all the elements that I've seen until now at that index in this variable called prefix sum, which is misleading because prefix sum means all elements before it, but let's just assume that it makes sense and move on. Then I'm also initializing a hash map counts. So I'm storing all of this, some of the elements that I've seen, and including the current element I'm at in prefix sum, and in counts I'm keeping the number of times that I've seen an element. And this is because I know for sure that my left and right pointers, whichever element that they point to, the value or the element at that place should be the same. So what I'm doing is I'm storing each of the indices of all. Basically, for each element I'm storing its indices of occurrence. So that's what counts has. And next I'm initializing answer, which is my final answer variable, which I'll return to 0. And I am going through each of the elements in counts, and I'm only looking at those elements which have which occur at least 2 times, right? Which only occur once, when we don't need to look at them, because we need at least 2. If they occur at least 2 times, then they have the chance of being one of the left and right pointers. So the next part of the solution just becomes finding the L and R, the left and right pointers, which satisfy the condition that all the elements strictly between L and R, the sum of all these elements between L and R is equal to the element that we're currently looking at. And I brute forced it over here. As you can see, I checked if the gap between, that we have at least one element between the left and right pointer, that is their definition of the subarray. And then I'm checking if it's not visible here. Yeah, so I'm checking if these sum of all the elements strictly between L and R is equal to the element or not. And that's just I'm doing that in O of 1 time using the prefix sum, which I had previously stored the sums in. And if that becomes true, I'm incrementing the answer variable by 1 and returning the answer. So it would be nice if that was it, a solution, but this gives you a time limit exceeded, because it would be O of k square if k is the number of keys of indices that you're looking at. I mean, if k is kind of the maximum, so you can just say that it's O of n square. So here k, we can say that it would be of the order of indices, of the order of occurrences of each of these elements, right? But either way, this gives you a time limit exceeded. So after a conversation with ChatGPT where it explained things very, very simply to me so that even I can understand, I optimized the solution. And let me show that to you. So it's a very small change. Most of the solution is the same. So as you can see, my prefix sum and my counts hash map are all the same in this. And even the for loop is starting out the same. We're going through all of the elements which have more than one occurrence. And now what I'm doing is I'm fixing a right pointer, and I'm questioning how many left pointers that I will find such that the sum of the elements in between the left and right pointer is equal to the element that I am at, right? So this is basically in the previous solution, if you remember, I was saying that I was comparing if the element was equal to the prefix sum of left pointer if the element was equal to the prefix sum of right pointer minus 1 minus the prefix sum of left pointer, right? So now what I'm doing is I'm just flipping the equation, where I say that I know my right pointer, so I solve for my left pointer, right? So I am going to find that prefix sum of left pointer such that that is equal to prefix sum of right pointer minus 1 minus the element value. So that's again, this equation is kind of diabolical because that's not what prefix sum means at all. But either way, so this is the logic for it if you look at the code. So over here you go through all of the right indices. So for each element you're going through all of the possible right indices. So right pointer, we initialize it to that index, and then we check until basically the left and the right index are not the same thing, and they make a valid subarray, which is a subarray of at least length 3. That's the second part of the condition in the while loop after and now I'm initializing my left pointer, and I am storing the prefix sum of that I'm getting at this left pointer in a hash map called freak L. So I am storing it, and then I increment the left pointer until we run out of valid subarrays basically. And then my answer will just be the number of left pointers for this right pointer for which the sum of all the elements between the left and right pointers is equal to the element. So that's what I said about flipping the equation, and then I returned that answer as I try to find, as we iterate through all the right pointers possible. So that is the first third medium hard Leetcode question that I solved, and I hope that you found my explanation useful. That's it for today. Thank you for watching.